Good morning students. Welcome to my YouTube channel, The Tactical Online Academy. This video is for the students who are preparing for the MBBS entrance examination. Today we are going to study one chapter from physics, that is vectors and scalars. I want to request all the students, please subscribe my channel and like the videos and comments in the videos and share the videos through your social media, and I'll be providing you the PDF of your course freely. Today we are going to study the chapter from physics, that is vectors and scalars. First of all, vectors are those physical quantities which have both magnitude and direction. Those quantities which are characterized by both magnitude and direction are known as the vectors quantity. It means vectors quantity has both magnitude and direction. For example, displacement is one example of vector quantity. Displacement is one example of vector quantity, and because displacement is the length of shortest path between initial point and final point, like this. The shortest distance between this initial point A and final point B is called displacement, and displacement always has the fixed direction. So displacement is one example of the vector quantity, and similarly velocity is another example of vector quantity, because velocity is the rate of change of displacement, and since displacement is the vector quantity, the rate of change of displacement, that is velocity, is also a vector quantity. And similarly another vector quantity, we can take acceleration. Acceleration is another example of vector quantity, because acceleration also has both magnitude and direction. So acceleration is another vector quantity, and similarly we can take another force is another vector quantity. Force has both magnitude and direction, so force is one of the vector quantity. And similarly weight is also a vector quantity, because weight also has both magnitude and direction. And we can take other example like momentum. Momentum is another example of vector quantity, momentum. And similarly another example we can take of vector quantity is the potential gradient. Like potential gradient is another vector quantity. If you see the word gradient, then you have to know those type of physical quantities are vector quantities. So potential gradient, and you can see any physical quantities having the word gradient, then if this gradient word is present, then that is surely a vector quantity. So potential gradient is also a vector quantity. And similarly we can take other example like electric dipole moment, like this. Electric dipole moment. Electric dipole moment. Electric dipole moment is also an example of vector quantity. So if you see the word dipole moment, then that type of physical quantity is vector quantity that you have to keep in mind. So I have given you some examples of vector quantity. Those physical quantities which have both magnitude and direction are called vectors quantity. And examples of vector quantity, I have said you the displacement, then I have said you velocity, and similarly I have said you acceleration, displacement, velocity, acceleration is also another example of vector quantity. And similarly force is also a vector quantity. Then after weight is also a vector quantity, momentum is also a vector quantity, like this. So these are the physical quantities which have both magnitude and direction, and those are called vectors quantity. Then now scalar quantity. Scalars are those physical quantities which have only magnitude but no direction. And that kind of quantities are called scalars. So let's see the examples of scalar quantity. Like distance is one of the example of scalar quantity, because distance is length of actual path traveled by a body from initial point to final point, and distance does not have a fixed direction. Distance only has magnitude. So distance is one of the scalar quantity. And similarly another we can take speed. Speed is the rate of change of distance is known as the speed. And speed also does not have direction, it only has the magnitude. So speed is another example of scalar quantity. And similarly, you have studied about the work. Work is another example of scalar quantity. Work also has only magnitude, but it does not have direction. So work is a scalar quantity. And similarly, energy is also a scalar quantity, because energy also has only magnitude but it does not have any direction. So energy is one other example of scalar quantity. And similarly power is also a scalar quantity, because power also only has the magnitude, it does not have direction. So power is another scalar quantity. And let's see some other examples, like temperature. Temperature is one more example of scalar quantity. Temperature also has only magnitude, like it is 5 degrees Celsius, 10 degree Fahrenheit, like this. So or 200 Kelvin, like this. So temperature only has the magnitude like this, but it does not have any direction. So temperature cannot be said like 5 degrees Celsius east, 5 degrees Celsius west, like that. So it only has the magnitude, it does not have any direction. So temperature is another example of scalar quantity. And similarly electric current is also another example of scalar quantity. And current is also a scalar quantity. Current has both magnitude and direction, but it is a scalar quantity. I just a few minutes later I am going to explain about this. Why current is a scalar quantity, I am going to explain detailedly. Current is also a scalar quantity. So those physical quantity which has only magnitude but it does not have any direction, those type of physical quantities are called scalars quantity. Like I have already said you, displacement, speed, for example of scalar quantities, distance is one example of scalar quantity. And similarly speed, and similarly work, energy, power, like this. Work is one example of scalar quantity, energy is also a scalar quantity, power is also a scalar quantity, and similarly temperature is also a scalar quantity. All these physical quantities have only magnitude, they do not have any direction. So these are called scalars quantity. So from here I think you have become clear. Vectors are those physical quantities which have only magnitude but no direction, and scalars are those physical quantities which have only magnitude but no direction. And vectors quantity have both magnitude as well as the direction. Now I am going to explain you about some confusing physical quantity like pressure. Pressure is first of all defined as the force applied per unit area. And the formula of pressure is force upon area. And force acting per unit area on a surface is known as the pressure. And pressure has both magnitude and direction. It has both magnitude and direction. And the direction of the pressure is like this. Suppose here is a surface like this. Here is a rectangular surface ABCD, and in this rectangular surface ABCD force is applied like this. Then the pressure acts perpendicular to this surface AB. That means pressure also acts in this direction. So pressure always has fixed direction, and it definitely has the magnitude. So pressure has both magnitude and direction. and the direction of the pressure is perpendicular to the surface. Remember that the direction of the pressure is perpendicular to the surface. But pressure is not a vector quantity. And similarly, let's see other example as well, like surface tension. Surface tension. You know, surface tension force is present at the surface of liquid, and if the liquid surface is like this, then surface tension acts in tangential direction, exactly like uh, if the surface of liquid is circular, then the surface tension acts in tangential direction like this, along the tangent in the circle. Like this, surface tension always acts in tangential direction. So surface tension also has both magnitude and direction, but surface tension is also not a vector quantity. And similarly, electric current, you know, current also has both magnitude and direction. Like you have studied the conventional flow of current, and according to conventional flow of current, the current flow from positive terminal to negative terminal, and according to the concept of electrons, the current flow from negative terminal to positive terminal, like this. So there are two concepts. Uh, According to conventional concept, current flows from positive terminal to negative terminal, and according to the concept of electron, current flow from negative terminal to positive terminal. But anyway, current also has both magnitude and direction. But current is also not a vector quantity. So I have said you three physical quantities, that is pressure. Pressure has both magnitude and direction, but it is not a vector quantity. And similarly, surface tension is also another physical quantity which has both magnitude and direction, but it is also not a vector quantity. And current also has both magnitude and direction, but it is also not a vector quantity. So I have said you all these three physical quantities as both magnitude and direction, but these are not vectors quantity. Like the direction of the pressure is perpendicular to the surface, and you know, surface tension force acts in tangential direction, and current also has direction. It flows from positive terminal to negative terminal according to the conventional concept, and according to electrons concept, it flows from negative terminal to positive terminal, but it also has the direction. So what is the reason behind this? Although pressure, surface tension and current have both magnitude and direction, but they are not vector quantity, because just having magnitude and direction is not enough to be a vector. The physical quantity is said to be vector only if it follows all the laws of vector. If it follows all the laws of vectors, then only those are called vectors quantity. Like the examples of vector, I have said you displacement, velocity, force, weight, acceleration, momentum, all those follow the laws of vector. But the three physical quantity, just before I have said you, pressure and pressure, surface tension and current. Pressure, surface tension and current. These physical quantity do not follow the law of vector. They don't follow the law of vector. That is the reason these are not vectors. I think you have become clear. Pressure, surface tension, and current have both magnitude and direction, but they do not follow the law of vector. Laws of vector means they do not follow like the triangle law of vector, parallelogram law of vector. They do not follow the polygon law of vector like this. Those laws are not followed by this physical quantity: pressure, surface tension, and current. That is the reason these three physical quantity has both magnitude and direction, but they are not vector quantity. So the vectors are those physical quantities which have both magnitude and direction, And scalars are those physical quantities which have only magnitude but they do not have the direction, and those are the scalars quantity. Now let's discuss some more point about the scalars and vectors. You know all the potentials. If the word potential is there, all the potentials are scalars. All the potentials. If you see the word potential, then that is the scalar quantity. Like it is like electric potential. Electric potential. Electric potential is a scalar quantity. And similarly, all the fluxes are also scalar. All the fluxes, all the fluxes are scalar quantity. All the fluxes are scalars. Let's see the example of fluxes. If you see the word flux in the physical quantity, then that is surely scalar quantity. Like electric flux, you may have heard electric flux. It is one example of scalar quantity. And similarly, magnetic flux. Magnetic flux is also a scalar quantity. Electric flux, magnetic flux, and similarly luminous flux, that means the flux of light. Luminous flux is also a scalar quantity. And similarly, let's see, heat flux, flux of heat flux is also a scalar quantity. All these are scalars. Electric flux, magnetic flux, luminous flux, heat flux. So these all are scalar quantity. All the fluxes. Now, another example like energy flux, momentum flux are also scalar quantity. So if you see the word flux, don't be confused, that is the scalar quantity. So I have said you all the potentials are scalar quantity, like electric potential, similarly gravitational potential. Electric potential, gravitational potential, both are the scalar quantity. And all the fluxes like it is electric flux, magnetic flux, luminous flux, heat flux, energy flux, momentum flux, all are the scalar quantity. So don't be confused. And similarly, another physical quantity like intensity of energy. Intensity of energy. Intensity of energy. All types of intensity of energy are also scalars. Like intensity of heat, intensity of light, like that, those are the scalar quantity. So remember these words, all the potentials are scalar quantity, like electric potential, magnetic potential, gravitational potential, all are scalar quantity. Then all the fluxes are scalar quantity, like luminous flux, magnetic flux, electric flux, heat flux, energy flux, momentum flux, all are the scalar quantity. And intensity of energy, all type of intensity of energy are the scalar quantity. Then now let's see another other point, like all the flux density are vectors. If the word flux density is there, then that kind of physical quantity is a vector. All the flux density. Now let's see the example, like magnetic flux density. We can take same example as before. Magnetic flux density, it is a vector. Similarly, electric flux density is also a vector. Magnetic flux density, and similarly electric flux density is also a vector. Electric flux density is also a vector. And similarly, we can take luminous flux density. Luminous flux density, So all these physical quantity, if the flux density word is there, then they are surely vectors. Like we can take other example, like we can say heat flux density, or we can take energy flux density, momentum flux density. All the types of flux densities are the vectors. And similarly, if you see the word gradient, like gradients are also vectors. Gradients are also vectors. Like if you see velocity gradient, it is a vector. Velocity gradient, velocity gradient. And similarly, we can take another energy gradient, like this. Energy gradient is also a vector. So if you see the word gradient, then you have to know that is surely a vector quantity. And similarly, if you see the word field strength, like electric field strength, magnetic field strength, like this, if you see the word field strength, that is also a vector quantity. Electric field strength, magnetic field strength, gravitational field strength are the vectors quantity. And similarly, if you see the intensities also, like electric field intensity, magnetic field intensity, uh, gravitational field intensity are the vector quantity. Electric field strength and electric field intensity, all are the vectors quantity. And if you see the dipole moment, if you see the word dipole moment is also a vector quantity, like electric dipole moment, magnetic dipole moment, like that. So dipole moment is also a vector quantity. So here are some ideas by which you can be clear whether it is scalar quantity or vector quantity. So in the today's video, I have explained you about vectors and scalars with their examples.